Hi everyone, you asked that I make a quick video to recap the discussion we had in class today regarding symmetry and even or odd functions. The first example that we're going to look at is as follows. We want to determine the symmetry and we want to determine whether or not the function is even or odd. And our function is y squared equals 2x to the fourth plus 3. Now we know that we can solve these graphically or algebraically. I'm going to talk you through the steps of how to solve this or answer these questions algebraically. First, let's test for symmetry with respect to the x-axis. If we're testing for symmetry with respect to the x-axis, we want to replace the y with negative y and see if we end up with equivalent functions. The original function was y squared equals 2x to the fourth plus 3, and we're going to replace this y with negative y. So we have negative y squared equals 2x to the fourth plus 3. A negative y squared is the same or equal to negative y times negative y, which is a positive y squared. So we end up with y squared equals 2x to the fourth plus 3. This is identical to the original function. They are equal. So our answer is yes. This function is symmetric with respect to the x-axis. Our next test is going to be whether or not this function is symmetric with respect to the y-axis. So again, we're testing to see whether or not it's symmetric with respect to the y-axis. So we are going to replace our x with negative x into the original function. The original function is y squared equals 2x to the fourth plus 3. We are going to replace the x with negative x. So we will have y squared equals 2. And again, we're replacing the x with negative x. We still have it raised to a power of 4, and we still have our plus 3. If we do the algebra to simplify, we will find that we have y squared equals 2. Negative x to the fourth is negative x times itself 4 times, which is a positive x to the fourth, and we still have our plus 3. Again, this is equivalent to our original function, so yes, y squared equals 2x to the fourth plus 3 is symmetric with respect to the y-axis. And that was our second test. Our third test is going to test whether or not this is symmetric with respect to the origin. And to test whether or not this function is symmetric with respect to the origin, we are going to replace both the x, I don't know what happened, the x and the y with negatives. The original function was y squared equals 2x to the fourth plus 3, and we are replacing both the y and the x with negatives. So we'll have negative y squared equals 2 times negative x to the fourth plus 3. We know from before a negative y squared is negative y times negative y, which is a positive y squared. And a negative x to the fourth power is also equal to positive x to the fourth. So we have y squared equals 2x to the fourth plus 3. So we will say yes. This function is symmetric with respect to the origin. Let's look at another example. Example number 2. And this time we have the function f of x equals 5x squared plus 2x to the fourth plus 1. We want to determine the symmetry, and then we'll determine whether or not this function is even or odd. The first test, we're going to test to see whether or not the function is symmetric with respect to the x-axis. So we will replace y with negative y, and we need to remember that f of x is function notation and it is interchangeable with y equals. So the original function is defined as y equals 5x squared plus 2x to the fourth plus 1. And to test for symmetry with respect to the x-axis, we need to replace this y with negative y. So we have negative y equals 5x squared plus 2x to the fourth plus 1. I'm going to solve it for y by dividing everything by negative 1. We're changing all of the signs. And we'll have y equals negative 5x squared minus 2x to the fourth minus 1. And that is not equal to the original. So the answer is no. This is not symmetric with respect to the x-axis. Our next test is going to be whether or not the function is symmetric with respect to the y-axis. So our function was f of x equals 5x squared plus 2x to the fourth minus 1. And we are going to test for symmetry with respect to the y-axis. Again, our function is y equals 5x squared plus 2x to the fourth minus 1. We're testing for y-axis symmetry, so we want to replace the x's with negative x. So we have y equals 5 times negative x squared plus 2 times negative x to the fourth minus 1. We'll do the algebra and we know that we're raising a base of negative x to even powers, so then it's going to become positive. That is negative x times negative x is positive x squared. So we have y equals 5x squared. A negative x raised to a power of 4 is going to be x to the fourth, so we have plus 2x to the fourth, and we still have our minus 1. This is identical to the original function. So then our answer is yes, it's symmetric with respect to the y-axis. We'll also say that this function is even because it has y-axis symmetry, or because we replaced negative x with x and we got the same function as our output.